guys, welcome back. So what we're looking at today is lesson 13, Polyhedra. So let's go ahead and jump right in. So what are polyhedra? Here are pictures that represent polyhedra. So we have this cube here, we've got this one here. All of these represent polyhedra. So polyhedra are three-dimensional shapes. So polyhedra are made up of filled in polygons, which are called faces. So notice we've got squares here, we've got triangles here, pentagons, more triangles yet again. The faces meet at what's known as an edge. So like this right here is an edge, edge. There's a lot of edges, and it encloses a 3D region. So remember, polygons are made up of line segments, which are known as edges. Edges meet at a vertex. Edges only meet at a vertex. And it's a 2D region. So that's what the faces of all of these need to be. So our other figures, we've got a sphere, a cylinder, this weird looking shape right here. We've got an open box. These are not polyhedra. This one's open. This is doing all sorts of crazy crisscrossing things that we just can't have. And the other two, well, the sphere and the cylinder, they're circular. So they're not straight edges. They're not line segments being put together. So a circle is not a polygon. So for number 2, we're not doing number 1, but for number 2, what features help you distinguish the polyhedra from other figures? So polyhedra are made from polygons. Polyhedra don't have any unattached edges, so no unattached edges. Non-polyhedra sometimes have curved or round surfaces, so no curved or round surfaces. So those are some things that we can use to take and distinguish between polyhedra and non-polyhedra. All right, so trying. I don't know why this won't scroll. Hang on. There we go. Yeah, I don't know. So this right here will help you understand what a face, edge, and vertex are, because I know those can be kind of confusing. So an edge, like it said, it's where two faces meet. So all of these are edges. This is just one example. A face, those are the flat sides. And the vertex is the point where multiple faces meet. So here's a vertex, 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 vertex. This is an edge, 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 edge. Lots of edges and vertexes in here. All right, so here are some polyhedra called prisms. So our prisms, these are all different prisms. This first one's a triangular. This one's a square prism. This one's another triangular prism. This is a pentagonal prism, another square prism, and a hexagonal prism. Here are some polyhedra known as pyramids. So triangular pyramid, square pyramid, pentagonal pyramid, and hexagonal pyramid. So look at the prisms. What are their characteristics or features? So coming back up here, looking at these. So you should notice they all have rectangular faces. So what's splitting your base apart is rectangles. So here we have a hexagon and a hexagon. Those are our bases. The faces are rectangular. So we have rectangular faces here. Some faces are parallel to each other. So some faces parallel. The prism may have two faces that are not rectangles. So 2 faces, not rectangles. So that's a key thing. So when I was naming these off, we've got the triangle, we've got a pentagon, we've got another triangle, we've got a hexagon. And remember, squares are also a kind of rectangle, so we can still call that a rectangular prism, even though it's a square versus a rectangle, because remember, a square is a kind of rectangle. So these are some of the features that you should notice about the prisms. So the key thing is they're separated by the rectangles. Now the pyramids, what are their characteristic features? So all faces are a triangle except one. Now that is true in all but one of these. So this one, all of the faces are triangular. So that's a unique one. It's a triangular pyramid. That's why. But the rest of them, it's always going to be the case that one side may not be a triangle, but all the other faces will be. All triangles share an edge. All triangles share an edge with this face. So all triangles share an edge with the base polygon. So depending on what that shape may be, whether it's a triangle, a square, a pentagon, a hexagon, a heptagon, an octagon, a nonagon, decagon, so on and so forth. All of the triangles are going to share an edge, with that. So they're all going to be touching it. And all the triangles meet at a single vertex. So that's one thing that helps you distinguish what kind of figure you have, is these are all going up to a singular vertex. So they all come to a point. They all come to that vertex. So you know that's going to be a pyramid when all but one of your faces meets at a single vertex. So for number 2, which of the following nets can be folded into pyramid P? Select all that apply. So a net is where we take and unfold the shape that we have, and then we can refold it back together. So nets can make it easier for us to find the area sometimes, depending on what our figures are or what we're trying to solve. So if we look at these, obviously we have a triangular base on pyramid P. So we need to make sure they're all triangles. They are all triangles, so all of them could work. So with this one, if we lift this up, let's make this the base. We lift this up, we lift this way. This one will come around to the front. Net 1 will work. Net 2, if we bring up each of these 3 triangles to meet at a center point above this one, we're going to have our pyramid. So this one will work. Now in this case, we could take and lift this one up, make this the base, lift this one up and lift this one up, but then this one, it's going to overlap. We're not actually going to end up with a triangular pyramid. So net 3 does not work for this. Okay, so nets can be kind of confusing when you don't have them to manipulate. It just depends. Sometimes it's not too bad, other times it is. It's a lot easier typically to create your own versus looking at a picture trying to decide if it matches. Now, obviously I'm not going to give you guys papers to cut out the nets and then fold to assemble polyhedron, but I am going to show you an example of a net. Now my net is not a true net because it has some extra pieces to it because it's technically a box that I've taken apart. But this is a net. So we're going to ignore this part down here. So we've got this right here for a rectangular prism. And this is my net. So we can lay it out all nice and flat. Now, to assemble this, we bring in all the different pieces. Now, obviously, in most of our rectangular prisms, we're not going to have as long on these. It's going to be only to here and here, sorry, to here, to give us those sides. Like I said, mine's not a perfect net, but notice we can fold this all together, and in the end, we end up with a rectangular prism. So our rectangular prism has 1, 2, 3, 4, 5, 6 faces. It has 1, 2, 3, 4, 5, 6, 7, 8 vertices. I got them all. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 vertices. So remember, vertices are the edge most point. And then edges, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I believe, unless I got a little off track. It can be kind of hard to count all your edges sometimes, unless you mark them to take and help you determine what edges you've already done. So edges, remember though, it's where two sides are meeting. So this is an edge because we've got two sides meeting here. This is an edge because two sides are meeting here. So that's the difference with edges and vertices. Faces are just the flat parts of it. Edges are the line where the two sides meet. Vertices are the point where multiple sides are meeting together, okay? So that's what you guys are looking at in this. Your keyword for this lesson is net. Net is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.